Kepler's law is one of the most amazing laws that astronomers have to work with. Versatile, used in all kinds of situations. We can use it in our own solar system. We can use it in another solar system. And we want to use it. We want to use Kepler's law right now to look at a very interesting situation in astronomy. In 2010, a group of 7 Australian astronomers announced that the newest planet had been discovered out in the universe, and it was orbiting a star that was almost, not exactly, but almost identical to our own sun. The same color, practically the same size, the same temperature, and this was a fascinating star. It's orbiting around its sun in 122 days. So what I'd like to do is use Kepler's law to try to find out what we can about this planet. Here's an artist's conception of what that star might look like. We don't really know. We don't see the star close up, just as we don't see the planet. But it's a fascinating situation, and it's in the southern constellation Centaurus, which is located right in this area, this part of the sky. Centaurus is amazing because it's got in it, right over here, a single star, Alpha Centauri, that is actually the closest star to us. We're not talking about Alpha Centauri in this situation, though. We're talking about another faint little star way over here at the other side of the constellation. And that star is visible to the naked eye, but you have to know where to look. You have to have a map to find it. It's this object right here. And that star is HD 102365. And if we look at that star, we can see that it wiggles. It moves back and forth. HD 102365 has got an invisible companion called HD 102365b, and that tells us that it's the companion to the star that we can actually see. We don't see the invisible companion, but we can see that it orbits around its sun once every 122 days. So here's my question. Given this invisible companion going around its star that's almost identical to our sun in 122 days, where is this star? Where is the orbit within the solar system of this system? And we've got to realize that this is only one of about 800 stars that astronomers have, or 800 other planets that astronomers have found out in the universe. But I've picked it just because it's got this interesting characteristic that its central sun is exactly like our star. The same color, same brightness, same temperature. If you were in this solar system and were orbiting around it, what would it be like? Where would you be orbiting on if you were riding on a planet in this that's just been discovered in this solar system? Well, let's start with Kepler's law and what we can do with it. And the first thing we have to realize is we're going to use p squared is equal to r cubed. And here's what we know. We know the period, 122 days, and we want to find the radius of the orbit. R stands for the semi-major axis of the orbit. And yet you start with the knowledge that this equation is true if you have an object in our solar system or in a solar system that has a sun exactly like ours, which is what we have here, and that you've got to have this quantity, p, measured in years. We've got it measured in days. But that's real easy to change. We can realize that this is the same as 122 days over 365. That'll tell us what the fraction is of a year, and that comes out to be 0.334 years. Okay? So that's the situation, and we want to find this. We're going to come up with the answer in astronomical units. It's real easy to do. 0.334, we're going to square that. When we square that number, we're going to come up with 0.112, and that's going to be equal to r cubed. That means if we want to find r, we got to take the cube root of this. The little 3 there tells us it's not the square root, but the cube root of 0.112. And you got to think about what that means. That means what's the number that if you multiplied it times itself 3 times, you'd come up with 0.112. And the answer to that, if you have a calculator and you work this out, what you'll find is that the answer is 0.48. And that unit, the units of that answer have got to be astronomical units. So let's interpret this. What have we learned about this thing? Well, we've learned that it's orbiting at a distance that's well inside the Earth's orbit. And in fact, this is moving, if it were in our own solar system, it would be orbiting between the orbit of Mercury and Venus and pretty close to Mercury. So it's at an incredibly hot place in its solar system. What would this object look like? Well, we don't really know, but we can measure through other mechanisms that we're not talking about here what its mass is, and we find that its mass is about 16 times the mass of the Earth. And that means that it's something like a Neptune, but instead of orbiting out 20 or 30 astronomical units from the sun like Neptune does, this thing is orbiting in by Mercury. It must be incredibly hot at its surface. We don't know what it's made out of yet, although that will be something that we will be learning as the years go by. You can guess maybe it's made out of gas, like Neptune, in which case it would be the size of this blue sphere here, drawn in comparison to the size of Jupiter. If we were comparing, you've got to have something to compare to. Over here is also to scale the Earth. Or if it were made out of rocky material, it would be like this red circle entire. It'd be more compact if it were made out of rocky material. So either way, it's a Neptune orbiting in the location in our own solar system about where the planet Mercury is. And we've learned this using Kepler's third law.